All right, diving right in today with a really cool topic all about AI,
Oh, nice.
specifically vector databases.
Okay, yeah, I've heard a bit about those.
So I was listening to this podcast about AI.
Yeah.
They had this guest on, Arjun. He's like an expert
Okay.
in vector databases, right?
Hmm.
But here's the thing, and this is kind of cool. He's also a huge origami enthusiast.
Really? That's interesting.
Yeah, and we'll circle back to that later.
Okay.
There's actually a fascinating connection between those two.
I'm intrigued.
But yeah, so the big thing here, by the end of this deep dive, we want you listening to really walk away understanding like three key things.
Okay.
First, how these vector databases actually work.
Mm-hmm.
But don't worry, we're not going to get all like tech jargony.
Right.
The second thing, why are these things so important? Why are they so important for the future of AI?
Mm-hmm.
Especially when we're talking about like chatbots and those large language models.
Yes, yes, those are definitely hot topics right now.
Exactly. And then finally, the third thing, we just want to give you a little taste of how fast this whole AI field is changing.
Yeah, it seems like every day there's something new.
Seriously. Even I was blown away by how much has happened in like just the past year.
It's remarkable.
So let's get into it. This guest on the podcast, Arjun, he actually had a pretty interesting path to AI.
Oh, how so?
It wasn't like he, planned this whole thing out from the beginning.
Yeah.
He kind of like stumbled into it.
Okay.
I think that's a really good point for anyone listening who's maybe new to AI, right?
Yeah.
It's not like some, exclusive club or something.
Exactly.
You can find your way in from all sorts of different backgrounds.
Absolutely. AI is a field that really benefits from diverse perspectives.
Totally. So to really understand like the impact of these vector databases,
Mhm.
we need to go back a bit, right? Like a little AI history lesson.
Okay.
Think about what's called classical natural language processing,
Mhm.
or NLP.
Right, right.
Basically, it was all about just analyzing text
Yeah.
based on how often words appeared.
Yeah, the old bag of words
Yeah.
approach.
Yeah, like almost judging a book by its cover, in a way.
Kind of, yeah. Effective for some things, but pretty limited.
Right. And the host of this podcast, he used this really great analogy to explain it.
Oh, I like analogies. What was it?
Imagine trying to describe a hot dog.
Okay.
You could just list out the ingredients.
Right.
Sure, bun, sausage, mustard.
Right, exactly. But does that really capture the whole hot dog experience?
Not really. It's more than just the parts.
Right. It's the taste, the texture, that whole feeling of summer.
The experience.
Exactly. And that's kind of what was missing in classical NLP.
Ah, I see.
So then things got really interesting
How so?
with this concept of attention.
Diction.
Yeah. And this totally revolutionized NLP
Okay.
because it allowed AI models to actually start to understand context.
Ah, so it's not just about the words themselves, but how they relate to each other. Exactly. Like take the word does, right?
Mm-hmm.
Means totally different things in these two sentences. Does this make sense?
Right.
Versus I saw some does in the forest.
Totally different meaning.
And attention helps AI figure out those nuances.
It's like AI is finally understanding the subtleties of language.
Exactly. But here's the thing. To make sense of all this context, AI needs a way to represent words and concepts mathematically.
Right. It has to work with numbers somehow.
And that's where these things called dense vectors come in.
Dense vector.
Think of them like these fixed size containers
Okay.
that are holding the essence of a word or idea.
Interesting.
It's actually kind of mind-blowing how AI can like pack so much meaning into these mathematical representations.
So it's like compressing the meaning into a numerical form.
Yeah.
Like, how does it do that?
It's pretty remarkable. And it allows for comparisons and calculations that wouldn't be possible with just text.
So then the question becomes, right, if AI is constantly learning all this stuff,
Where does it all go?
right, where's the storage?
Is there some kind of knowledge graph where it's like storing everything?
Yeah, some sort of AI brain.
Yeah. And then there's this whole idea of tokens
Tokens.
being like the building blocks of knowledge for AI,
Okay.
like how pixels are for images.
So like AI's way of breaking down information into fundamental units.
Exactly. And even like the CEO of NVIDIA,
Wow.
he's talking about this now,
Yeah.
describing AI as a token factory.
A token factory. So it's not just processing information, it's creating it.
Yeah, that's a really interesting way to think about it. Like we're moving past just, processing information and into this era where AI is like creating and manipulating knowledge through these tokens.
It's a whole new level of AI.
Yeah.
And with it, a whole new set of challenges. Like, how do we make
Yeah.
sure it's creating accurate and reliable knowledge?
Right, right. And that actually leads us to, well, a bit of a problem.
Oh, what's that?
These large language models,
Yeah.
or LLMs for short. Sometimes they can just make things up.
Oh, that's not good.
Yeah, not exactly ideal if you're relying on them for like accurate information.
Definitely not. So how do we address that? How do we make sure these LLMs are grounded in reality? That's where these vector databases come in.
Oh, okay.
They're like a sort of reality check for AI, you know?
Interesting. So how do they do that?
Well, think of a vector data like a giant library, right?
Okay, yeah.
But instead of being organized by like traditional categories,
Mhm.
it's organized by the meaning, you know,
Okay.
encoded in those dense vectors we were talking about.
Ah, I see.
This allows AI to like search for information based on conceptual similarity,
Oh, okay.
not just matching keywords.
So instead of just looking for like the exact phrase hot dog recipes,
Exactly.
it could search for like summer cookouts or classic American food.
Right.
And still kind of find what it needs, even if those like exact words aren't there.
Exactly.
That's pretty cool.
It really opens up like a whole new world of possibilities for AI, you know?
Yeah.
Allows it to connect ideas and concepts in ways that just weren't possible before. And it leads us to this really important concept called retrieval augmented generation.
Retrieval augmented generation.
Well, RAG for short.
RAG. Okay.
Yeah. I know it sounds like technical, but it's actually pretty straightforward.
Okay, good.
And it's crucial for you to understand how AI is like getting smarter, you know?
So break it down for us. What is RAG all about?
So imagine you're asking an LLM to like write a report on a specific topic, right? Instead of just letting it loose on the entire internet, Raggy gives the LLM a carefully selected set of relevant documents from the vector database.
Oh, okay.
It's like giving the LLM like a crash course on the topic before it starts writing, making sure its output is accurate and grounded in reliable sources.
So it's like giving the AI a cheat sheet, basically.
Exactly.
Before an exam.
Yeah. Raj acts as like a safety net for LLMs, right?
Yeah.
Prevents them from going off on tangents or making things up. It's a really powerful technique for enhancing the reliability and trustworthiness of AI systems, you know?
Now, this podcast that I was listening to, they mentioned this this pine cone, which is like a specific type of vector database.
Oh, right.
What makes that one stand out?
Well, Pinecone is known for its efficiency and scalability, right? Which means it can handle like massive amounts of data
Okay.
required for like modern AI applications.
But it's like a really high-powered like search engine?
Yeah, you could think of it that way.
Okay.
But built specifically for the complexities of semantic search and RAG.
Speaking of AI changing how we work, I've been playing around with these code generation tools.
Oh yeah.
Like Copilot.
Copilot.
It's crazy how AI can like assist with coding now.
It's pretty remarkable.
Like it's suggesting code snippets and even anticipating what you're trying to do.
Oh.
It's almost like having a coding partner, even if you're working solo.
That's a great way to put it.
The podcast host, he also mentioned this this paper
Okay.
called Raft, which apparently is similar to something that Red Hat is doing called retrieval augmented fine-tuning.
Retrieval augmented fine-tuning.
Yeah. Could you maybe explain that a little bit?
Sure, yeah. So both Raft and retrieval augmented fine-tuning, they share the goal of making LLMs more accurate and effective.
Okay.
By incorporating like relevant knowledge from a specific domain.
So it's not just about making LLMs like smarter in general.
Right.
It's about making them like experts in specific areas.
Exactly.
That's really interesting.
It opens up a lot of possibilities, you know?
Yeah.
For businesses and organizations looking to use AI for very specific tasks, you know?
And this is all happening so fast.
Yeah. I know, right?
It's a bit overwhelming, to be honest.
Yeah.
The podcast guest, he was talking about how instruction fine-tuning has made it so much more natural to interact with LLMs.
Oh, yeah.
Like we can just ask them questions directly now and get answers.
Right.
Instead of having to like figure out all these tricks to get the AI to to understand what we want.
It's becoming much more user-friendly.
Yeah, exactly. Okay, let's shift gears for a second.
Okay.
Remember how I mentioned that our guest loves origami?
Oh, yeah. The origami enthusiast.
Yeah. Well, there's actually a surprising connection here.
Oh, what's that?
Origami involves a lot of, like, complex math
Right.
and spatial reasoning,
Mm-hmm.
which those skills actually translate really well to the world of AI and data science.
Oh, wow. That's fascinating.
Yeah, it's a really cool example of how, like, seemingly unrelated fields can connect in unexpected ways.
I love that.
It's like that saying, everything is connected.
Mm-hmm.
Who knew that folding paper could be, like, such great training for working with complex AI systems?
It's a good reminder that that knowledge and skills can often transfer across fields, you know?
Yeah.
It highlights the importance of interdisciplinary thinking and exploration. And it brings us back to our central topic, you know? How do we ensure these increasingly powerful AI systems are grounded in accurate and reliable information?
Right.
That's where vector databases and RGED really shine.
It's really wild, right, how all these pieces fit together.
Yeah, it is.
And it makes you wonder, what else is out there, you know?
Yeah.
What are the connections we haven't even thought of yet?
Definitely. There's so much potential still.
But with all this potential comes, like, a responsibility too, right?
Absolutely. We have to be careful.
We got to make sure AI is learning from the right sources.
Exactly. Garbage in, garbage out, as they say.
So let's do, like, a quick recap just to make sure everyone's on the same page here.
Okay, sounds good.
We started by talking about how AI evolved
Right.
from just analyzing words to actually understanding the context.
Right, with that attention thing.
Exactly. And that made those large language models, or LLMs, possible.
But they're not perfect, are they?
Not quite. They can still make stuff up.
Especially if they don't have the right information to work with.
And that's where vector databases and Argy step in.
Our trusty guides.
Think of those dense vectors as, like, a code that AI can use to grasp meaning, not just the words themselves.
Right. It's about understanding the concepts behind the words.
And Argy, it's like giving AI a focused study guide before it tries to answer your question.
So you can be more confident in the answers it gives you.
Remember Arjun's vision about using AI to make high-quality education free for everyone.
Oh, yeah, that was inspiring.
I think that's something you really get behind, knowing how much you love learning new things.
Oh, absolutely. Knowledge should be accessible to all.
Okay, so here's a final thought for everyone listening, and it brings us back to that origami thing.
Okay. Intrigued.
Imagine you're folding a piece of paper to represent a vector database. What would that look like?
That's a good one. Lots of layers, I imagine.
Think about all those intricate connections and how this one shape, this one piece of paper can hold so much information.
A whole universe of knowledge folded into something simple.
Keep exploring, keep questioning.
Yeah,
Who knows, maybe you'll be the one to come up with the next big breakthrough in AI.
that's the beauty of it. There's always something new to discover.
Until next time.